Alright guys, welcome to our channel once again. Today you'll learn about isomerism. So isomerism is simply a phenomenon where organic compounds exhibit the same molecular formula but differ in the arrangement of their atoms. So although the compounds may have the same molecular formula, they have different physical and chemical properties. So these compounds are known as isomers or isomerides. So there are two basic subdivisions of isomers. These are structural isomerism and stereoisomerism. So we can classify isomerism here as either structural. So I have structural isomerism and then stereoisomerism. So the structural isomerism can further be subdivided into three main types. So we have number one, the chain isomerism. Chain isomerism. So we have again number two, the positional isomerism. And we also have functional group isomerism. So the stereoisomerism can be grouped into two. So the two major types are optical isomerism and then geometrical isomerism. So having known this, we'll go ahead and proceed with the structural isomerism. So like we said earlier on, the structural isomerism can be of three main types. These are the chain isomerism, also known as nuclear isomerism, so we have number two, positional isomerism, and then we have the third, functional group isomerism. So I'll go ahead and wipe this. So it is also important for us to note that structural isomers are also known as constitutional isomers. Alright. So let's consider the first type of structural isomerism, which is the chain or nuclear isomerism. So the chain isomers differ in the arrangement of the carbon atoms in the molecule. For instance, if I have and then I also have CH3, CH3, and then a methyl over here. So this is N-butane. Now notice that this has the structural formula C4H10, and this is 2-methyl propane, because methyl is at the carbon 2, so I have 2-methyl propane. So this will also have the formula C4H10. So notice that this is a branch chain while this is a straight chain. So this is known as an isomer of this because they have the same formula here, but they have different arrangements here, where this is a straight chain, this is a branch chain. So in this situation, this is a chain isomerism. So I'll go ahead and show further examples. So what if I have CH3, CH2, 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 and CH3. So this is 1, 2, 3, 4, 5. So this is N-pentane. So notice that this is a continuous chain, a straight chain, but I can also have a branch chain that will have the same formula as the one above here. So let's say this is CH3, and this is CH3, this is CH3. So this compound is 2-methyl butane, and it is branch chain. It is a branch chain. So this is another example of chain isomerism here. So this is a continuous chain, a straight chain, whereas this is a branch chain. So next, let's consider the positional isomerism, which is the second type of structural isomerism. So the positional isomerism, organic compounds that have the same carbon skeleton but differ in the position occupied by a subsequent group are said to be positional isomers. Now, for instance, if I should have CH3, CH2, CH2, OH. Now, what's this? This is propanol. And when I have this CH3, CH bonded to OH, and then CH3. So this compound is 2-propanol because the alcohol group is at carbon 2 here, whereas the alcohol group is at the H at carbon 1 here. So this is propanol and this is 2-propanol. Now these two compounds are positional isomers. So the phenomenon here is that of positional isomerism. I'll go ahead and talk about the third type of structural isomerism, and that's the functional group isomerism. So this type of isomerism occurs in compounds with the same molecular formula which possess different functional group. Now, for instance, if I have CH3, CH2, OH. Now what's this? This is an ethanol. And then if I have CH3, O, CH3. Now what's this? This is dimethyl ether. So notice that this has the formula C2H6O, and then this also has the formula C2H6O. So they both have the same formula, but then they differ in the functional group. Now this is having an OH functional group, while this is having an O functional group. So this is a hydroxyl, so this is an oxo, which is an ether. So you see this as dimethyl ether, and then we see this as an ethanol, which is having a hydroxyl group. Alright, so this is a good example of functional group isomerism. So another example of functional group isomerism is this. So perhaps we have CH3, CH2, CH2, and then CHO. So what functional group is this? This is an aldehyde. So this compound is 1, 2, 3, 4, a butanol. Which is an aldehyde. And then I can have this structure, and then this is typically a ketone. So what structure is this? This is butan 2-on. So this is 1 carbon 1, this carbon 2, this carbon 3, this carbon 4. So I'll have butan 2-on, which is a ketone. So notice that these two will possess the same formula, that's C4H8O. Alright, so having known this, let's consider the stereoisomerism. So let's understand that stereoisomerism is an aspect of stereochemistry, and it is exhibited by isomers which have the same structures but differ in their configuration. So we have basically two types of the stereoisomerism, of which number one is the geometrical isomerism, and then we also have optical isomerism. So when we talk about geometrical isomerism, we talk about the cis and trans isomers. So for instance, some molecules have restricted rotation around a bond because of rigidity of the molecules. So this hindered the rotation around the carbon-carbon double bond. Examples are alkenes. So this leads to geometric isomers. Cis-trans is another way of referring to geometrical isomers. So let's quickly look at this example. If I have this structure, and this is H, and this is CH3, and this is CH3. So I can name this compound as cis-2 butene, whereas if I have this is a CH3, and I have H over here, so let's say I have CH3 here and I have H over here. So notice that this is trans, so I call this trans 2 butene. So this is typically how geometrical isomers seem to be. So they are just mainly the cis and trans isomers. So you see this on the same side as this, that's cis. So when this gets to reverse this way, it's a trans. So in geometric isomerism, the molecules differ in their relative positions. So you have a cis-2 butene and then you have a trans-2 butene. So I'll go ahead and wipe this. So the next type of stereoisomerism is the optical isomerism. So optical isomers are molecules whose structures are mirror images but cannot superimpose on one another in any orientation. Now, molecules with non-superimposable mirror images of each other are called chirals. Now, for instance, your palm oh, wow. If I have my palm here and say the other palm, oh wow. So let's say this is the left palm and then this is the right palm. Now these two palms cannot be superimposed. If I lay this palm on this, I'll get something like this. And then this other on top will have my thumb down here, and then this. So you notice that they are not superimposable. So as such, they can be referred to as chirals or chiral objects. So optical isomerism is actually displayed by compounds which have the same structure but different configuration. So for instance, if I have bromochlorofluoromethane, which is so this is bromo chlorofluoromethane. So a mirror image of this will have this bromochlorofluoromethane. So this compound is bromochlorofluoromethane. So this is an example of a compound exhibiting optical isomerism. Alright guys, so that will be the end for the class. If you enjoyed this video, please give it a thumbs up. Also share with your friends and comment on the comment section below. Please ensure to hit the subscribe button right away. Thank you.